In this video, we're going to review the incenter of a triangle. So the incenter of a triangle is where the angle bisectors meet. So angle bisectors means the angles are getting split in half. So we see that happening at each angle in the triangle. It's getting split in half. So where all those lines are meeting, where AP, CP, and BP all meet, because those are my angle bisectors, we call that point the incenter. So that's point P. So there's a few sets of lines that will be congruent when you have an incenter of a triangle. Those lines include DB will be congruent to EB. So that's this first set that we have written there. EC would be congruent to FC. So that's that second set. AF would be congruent to AD. And then the last set, it's not going to be part of the sides, that would be congruent, is going to go from the incenter to the sides, perpendicular to the sides. So those three sets of lines are congruent with each other. So that's what we have here. We've got those three sets. So you've got three different line segments congruent to each other. So this is similar to circumcenter. It's a little bit different though because the sides are not cut in half. As you see, it's the parts that are meeting in the corner and the angles that are congruent. So that's where it's a little bit different. With circumcenter, the sides were cut in half. So that's the definition of incenter and which congruent parts it gives us. So we're going to look at the first example in your notes. So we have an incenter in triangle JKL, and then we're trying to find a few different lengths. So remember, the incenter is where the angle bisectors meet. So that means all of these angles are cut in half. And then the sides that are meeting at the corners are the ones that are congruent here. So it's a little bit different than circumcenter. Those sets of sides are congruent. In addition to those, if you go from the incenter perpendicular to the sides, those three lengths are all equal to each other. So we need to use these to help us find these different lengths. So you could put any numbers that you do know at this point into other places. So I could put 17 here because of that 17. I could put 8 where all those gray lines are. Okay, so first thing we're looking for is NP, which we already have there, is 8. Because these gray lines are all equal. I had this one as 8 given to me, so they are all 8. Next one I'm looking for is NK. I also wrote NK down already. These two blue lines were congruent. So NK is 17. The next one I'm looking for is PK. So for PK, it's not congruent to anything, so we're probably going to need to use the Pythagorean theorem. So I see Pythagorean theorem with this triangle there. So that's the triangle I'm going to use to do the Pythagorean theorem. So I'm going to put my right angle in. This side is 17. This is 8. And then PK is what I was looking for. So make sure you go across from your right angle. Label that C. Other two you call A and B. So we're using A squared plus B squared equals C squared. So it looks like 8 squared plus 17 squared equals x squared. So 8 squared gives us 64. Plus 17 squared is 289. Equals x squared. So we're looking at 353 equals x squared. So now we got to take the square root. So the square root of 353 we get x to equal 18.8. So PK is 18.8. And then we're looking for LO. So LO we have right here. So both those red segments are the same, but we don't have either of them. So it looks like we're going to need to do Pythagorean theorem again with a different right triangle. So the right triangle that I see here is this one. So we're going to use that right triangle, put your right angle in, and then put the measurements in. So this was the side that we were looking for. Here's 13, and then this was 8. Go across from the right angle is your C, and it doesn't matter which ones you call A and B. A squared plus B squared equals C squared. So x squared plus 8 squared equals 13 squared. So we get x squared plus 64 is going to equal 169. Subtract 64 from both sides, and you get x squared to equal 105. And then we're going to take the square root of 105. It gives us about 10.2. So LO is 10.2. Now we're going to look at example 2 in your notes. So once again, we have an incenter, and we have some sides that we're looking for. So I'm going to start off by marking everything that's going to be congruent. I'm going to use colors. You can use tick marks. So the outside sides, and then we also have the lines that are perpendicular will be congruent. So all three of those are congruent. So now that I have everything marked off that's congruent, I'm going to put anything in the picture that I know. So I know over here is going to be 35. I know over here will be 6. Okay, so the first thing we're looking for is GD. GD is this green segment right here. Looks like we're going to need to use the Pythagorean theorem for this. So I'm going to use the Pythagorean theorem with this right triangle. So I'm going to draw that right triangle outside of my picture. Right angle, 35 is on the bottom, 37, and then that's what we're looking for. So this is C, A, and B. A squared plus B squared equals C squared. Plug everything in. So we've got x squared plus 35 squared is going to equal 37 squared. So x squared plus 1225 is going to equal 1369. subtract 1225 from both sides, and we get x squared to equal 144. Take the square root, and that gives us 12. So this side would be 12. So that's GD. The next thing we're looking for is BG. BG is this part right here. It looks like we're going to need to use the Pythagorean theorem again. This time I'm going to do it with this right triangle. So I'm going to draw that outside of my picture. Here's my right angle. This side is 6. This is what we're looking for. And this green side, from E to G, we know is the same as the other green side, which we just found to be 12 in the last problem, because we just found that to be 12. So we have 12. Now we're going to use Pythagorean theorem. So I've got my C labeled across from the right angle. A squared plus B squared equals C squared. 6 squared plus 12 squared equals x squared. So I have 36 plus 144 equals x squared. 180 equals x squared. Take the square root. We should get x to be 13.4. So that is our second question. The next one is FC, which we already have figured out when I labeled everything that was congruent to be 35. And then the last one is BF, which we also already have figured out to be 6 when we figured out everything that was congruent. So that's using Incenter to find the different measurements within triangles. Remember, it's different than circumcenter, so you have to pay attention to the differences between those two. You now have problems in your packet to complete that I'll be looking at tomorrow.